Okay, year 11, so back here at 511, I'm now going to have a go at 5i down here. And this one is y equals x plus 1 on x. Now that's a useful form to have it in when we're going to find any asymptotes as x approaches infinity, but it's not too useful for helping me sketch it. So I'm going to now write this equation all as one fraction. So I'm going to write this as, oh, well, that's x squared on x plus 1 on x. Oh, and now I've got a common denominator, so I get x squared plus 1 on x. So what I'm going to do now, well, x can't equal 0. Beautiful. That's one vertical asymptote, so I've got a VA. Also, when x, therefore I know that x can't equal 0. I was just about to try and find the roots. And I know that y can't equal 0 because there's nothing that can make the top part of this equation equal 0. There's nothing in there because I can't make the x squared equal 0, so it has no, so therefore y can't equal 0 either because it has no way that that x squared can equal minus 1 to make the top equal 0, hence y cannot equal 0 either. Now, because it's now in this form, x squared plus 1 over x, let's try f of minus x. We go, okay, well that gives me minus x all squared plus 1 on x, which gives me, minus x, which gives me x squared plus 1 on negative x, which gives me negative x squared plus 1. I can just put that out the front, which equals negative f of x, which means this equation, this function is odd. Okay, so that's great. I only have to draw half of it. Let's go back up here and have a look at this form of the equation now, this one. And let's use it to find the limit as x approaches infinity. Now we only have to find positive infinity. If you remember, well, we didn't do question 3, but sometimes you might have to find what happens as it goes to positive or negative infinity. But because this is an odd function, we only have to go to one side and then we can rotate it. And we're finding the limit as x approaches infinity of x plus 1 on x. Oh, this is great. This is something very easy because that's going to equal, well, as x goes towards infinity, y goes towards x, and this bit here, this 1 on x, goes towards 0. So we have a limit here, an asymptote here of y equals x, a oblique asymptote. Okay, so what have we got? Let's have a look now. And did it again. This is ridiculous. Come on, let me get in here. So, there we go. And we'll move it over to there. And we'll get rid of those strokes I made. So what do we have? Well, we know that y can't equal 0. We know that x can't equal 0. And we know that y can't equal x. We also know that it's odd, and we know that as x gets bigger and bigger and bigger, as x approaches infinity, y will approach x. So it's getting close now, but the trouble is it approaching that from there, or is it approaching it from here? I don't know. And is it approaching this one there, or is it going down here? I don't know. Well, I better check that. So let's see. As x approaches 0 from the negative side, from the positive side. So let's see what happens as x approaches 0 from the positive side. So let's let x equal 0.01. We'll go to the original equation. So y will equal 0.01 plus 1 over 0.01. And if I go to my calculator, so I've got 0.01 plus 1 divided by 0.01. Oh, 100.01. So that's going to be going up positively. So if I look here, it's going up that way. Now, I know it's not going to cross that asymptote. There's no point of discontinuity. So something has to happen where this then comes and approaches that bit. I don't have to find out what happens as x because I know it's already on that side. And then if I rotate that through 180 degrees, I'll get exactly the same thing there. And that's easy enough to draw. I'm going to get it there and there. And that is a graph of y equals x plus 1 on x. Now, it could be important to find where this thing sort of turns around, but we're not up to that yet. We could keep guessing and we could keep picking values. Remember, you can keep picking values. I did 0.01. If I wanted to, I could pick a few values here. So I could pick, 1 for x, and I'd get, 1 plus 1 on 1 is 2. I could pick 2 for x, and I get 2 plus 1 on 2, or 2.5. Pick 3 for x, and I'd get 3 plus a third. And as you can see, that reinforces what I was doing. It's getting closer and closer to the original one. So 4, 4 1/4, 5, 5 1/5, 100, 100, and 100th. And you can see what's happening. So there you go. That's that function, y equals x plus 1 on x. And that wraps up exercise 511 question 5, except for J, but really you should be able to do that one on your own by now.